Hello students, here we are starting with the science part 2 lesson number 6. Now the first one, sterilized measurement. Take a ball of string. Let one student from the class measure 4 handspans of the string and cut it there. Let each of the other students in the class cut 4 handspan of the string too. Now hold all the pieces together by one end. Are they all the same length? No. Now measure the length of a bench by means of the span of your hand. Ask your friends to do the same. Did each of you obtain the same measure for that bench? No. What could be the reason? Size of your hand. Standardized measures are required for measuring things. Such measures are called standard unit. We have to measure many physical quantities accurately. To measure any quantity, we use the unit specified for it. For example, the meter m is the specified unit for measuring length. A certain distance has been accepted as the standard for 1 meter. Why is there a need for such a standard unit? Can you say me? Suppose the span of a hand is accepted as the unit for measuring length. With this unit, we can measure lengths of cloth as 2 handspan, 3 handspan and so on. However, the length of the cloth measured by each one of us will come out to be different. That is why a handspan cannot be a standard unit for measuring length. Now, always remember, prevailing system of measurement. First, MKS system. In this system, distance is measured in meters, mass in kilogram and time in seconds. Now, CGS system. In this system, distance is measured in centimeters, mass in gram and time in seconds. In the MKS system of measurement, distance, mass and time are accepted as the fundamental quantities. These three quantities are used to measure all other quantities. Now, we will see this table: physical quantity, MKS and CGS. Now for mass, what will be the measurement? Kilogram. For CGS, gram. Now distance, how to measure it for MKS? Kilometers, and for CGS, meter. For time, seconds, CGS, also seconds. Speed, kilometer per hour, and in CGS, meter per second. There are many physical quantities, but a majority of them are related to each other. For example, you have learned that the quantity speed is the ratio of the quantities distance and time. Now we will see fundamental quantities. It is enough to select a few out of the many quantities and standardize their units. You can see from the above example that units of the quantities, length and time need to be standardized. Such quantities are called fundamental quantities and their units are called standard units. Of course, a standard fundamental unit must be available to all and it must not be variable. Now we will see international system of unit. An international system of units based on 7 fundamental units called the System International (SI) is currently used all over the world. It is also called the metric system. The names and symbols of the units of the fundamental quantities, length, time and mass in this system are given in the following table. Now we will see that quantities, name of the unit, symbol of the unit. Length, meter, symbol m. Mass, name of the unit is what? Kilogram. And symbol is what? Kg. Time, name of the unit is what? Second. And what is the symbol? S. Standards of the fundamental quantities. As the standard of mass, a solid cylinder made of a platinum iridium alloy is kept in the International Bureau of Weights and Measures at Paris. As per the international agreement, this mass is called 1 kilogram. Official accurate copies of this prototype are kept in the standardizing laboratories institutes all over the world. Now, what is prototype? A prototype is an early model built to test a concept. Two fine lines are engraved on a platinum iridium bar kept in the International Bureau of Weights and Measures at Paris. Can you see that line? The distance between these two lines is accepted as the standard meter. Accurate copies of this prototype are made and distributed to standardizing laboratories institutes all over the world. The time required for one revolution of the earth is measured by means of an accurate device. This time is taken as 24 hours. To standardize 1 second, 1 hour is considered to have 60 minutes and 1 minute, 60 seconds. Now we will see importance of accurate measurement. How accurate a measurement must be depends upon its purpose. Accordingly, an appropriate device has to be used for the measurement. Measurement of substances that are precious, of great importance and used in very small quantities is done meticulously and accurately. Now, what is meticulously? With great attention to detail. Due to advancement in technology, devices that measure very small magnitude of quantities like distance, mass, time and temperature are available now. For example, distance and time in connection with very important sports competition, mass of gold, body temperature, etc. can be used. Major causes of error in measurement. Not using the appropriate device, not using the device properly. Make a list of possible error other than these if you can. Now, do you really get as many liters of petrol as the petrol pump indicates? What do you think? To ensure this, it is necessary to check it against a standard measure from time to time. This is called standardization. Similarly, it is necessary to standardize the weights and measure used in the market. While buying things at grocery shop, the vegetable market, remember to look out for the following and tell your guardians to do so. Does the balance carry the stamp of standardization by the Department of Weights and Measures? Is the balance stable? Is the pointer of the balance upright? Is the weight made of metal? How is the balance held? Has the underside of the pan of the balance been tampered with?